Hello students, and today we're going to look at solving equations and literal equations. What you're going to want to have near you today, you're going to want your notebook, some form of a writing utensil, and then you may want a calculator, but it's kind of sketchy if you'll need one. Here are your learning targets for today. You're going to learn how to solve multi-step linear equations, which is not too new, and then isolate a specific variable using mathematical operations, which is also not too new, but we're just going to make sure we know how to do it. So basically, what does it mean to solve? To solve something means to find a solution or solutions that make an equation true. So to find the value, we're going to find, let's say, x equals 4, and then if we plug that in, that means that it's going to be equal. Both sides are going to be equal. That's what we're actually doing when we're solving an equation. Now, let's take a look and try to jog our memories of how to solve an equation. So, very first thing that I notice is I have parentheses. So, I'm going to do the distributive property. So, I'm going to distribute this 3 in and the negative 2 in on both sides. So, I have 3 times x, which is 3x, and 3 times 4, which is 12. This side, negative 2 times x, I get negative 2x, and negative 2 times negative 5 is a positive 10. So now what I need to do is I need to further get the x's to one side and the numbers to the other. So I'm going to add 2x to both sides. So I'll get 3 plus 2, that's 5x. Okay, just rewrite the rest. Get my numbers to one side. So I'm going to subtract 12 from both sides. Get 5x equals negative 2. And then get x alone, so we've got to divide by 5. And we'll get x equals negative 2/5, which is my final answer. We're going to leave it in fraction form just because it's fractions. So now, what is a literal equation? Well, literal equations look nothing different than what we just solved. It's an equation with more than one variable. You see these all the time in science. With chemistry, you have the ideal gas laws, you have density, you have D equals RT. Physics, with kinetic energy, and even in geometry, when you had a squared plus b squared equals c squared, and you had to solve for b squared. So what we're going to take a look at is, how do you solve for a particular variable when you don't even have numbers to deal with? Here's an example. Circumference equals 2 pi r. So this is your formula finding your your circumference of a circle. So I need to find, let's say I want to solve for r, our radius. So I need to get r alone. That's our job. Whoops. I need to get r alone, right here. How am I going to get r alone? Well, I need to get rid of this 2 pi right here, right? So right now they're multiplied. You agree with me on that? I have 2 times pi times r. Well, why can't I divide by 2 pi? That's just a number, right? 2 pi? 6.28 something something something. So on this side, the left, I'll left with c over 2 pi equals r. I have solved for r. I'm done with the problem. Pretty simple. You just got to think of it as, how would I have normally have solved this if I would have had numbers? So let's take a look at this. We need to solve for a variable. We need to solve for x. Notice how I already have a b in there, so this is probably, I haven't found my y-intercept yet. I need to get x alone. Very first thing, treat this b as a 2. So if I would have on x alone, I would have subtracted that 2, right? So I'm going to subtract b on both sides. So I'll be left with y minus b. On this side, I'm left with 3/4 x. Okay? Need to get that x alone. So let's do the reciprocal of 3/4, which is 4/3. It's going to multiply both sides by that. Put these guys in parentheses here so I don't forget about it. And then I'm going to distribute that in. So I'm going to get 4/3 y minus 4/3 b equals x. This would have also worked. This is an also possible answer that I would accept on a test. Okay? Either of the two circled answers I would accept. What about this? So let's say we have a standard equation And we need to solve for y. You've done this before. This is actually not too new for most of you. So we need to solve for y. So very first thing, let's get this 8x to the other side. So I'm going to subtract him. And I'm going to be left with 3y equals, and I'm going to write it kind of like the linear equation formula, negative 8x plus 48. I need to get that 3 away. Let's divide by 3. And I'll be left with negative 8 thirds x plus 16? Yeah, 16. There we go. Let's try this one. We need to solve for r. Notice, there's a lot more stuff going on in this one, but don't worry, it's going to be okay. First thing, let's get this 2x out of there. There's nothing going on with it, so let's subtract 2x from both sides. And I'll have p minus 2x equals 2 pi r. Okay? Just kind of like we had 2 pi r with our circumference formula, I'm going to divide by 2 pi. Whoops! So I'm going to have p minus 2x all over 2 pi equals r. Notice I'm not going to simplify that. That's actually done. It looks really gross. Don't get me wrong. But it actually is done. It's actually a good answer. And it's acceptable. You solved for r. That's all you needed to do. Is it kind of gross? Yeah, but that's okay. You solved for r. Now, let's solve for a. Notice a is in the top. So we got to get rid of that denominator so we can actually mess around with the numerator. So I want to multiply by 12 on both sides. I'm going to be left with, on the left, AB plus 8 equals 12C. And then I'm solving for A. So let's get rid of this 8 here, because that's just kind of hanging around right now. It's not multiplied by, so I'm going to undo it with this subtraction. 12C minus 8. And now I need to get rid of B. So I'm going to divide by B. And I'm done. I solved for A. That's all I cared about. I just want to know what A is equal to. Is that a little gross looking? Yeah, but that's okay. That allows me to plug in variables a lot faster. Then I don't have to solve after I plug in. And that's the end of my video. See you later, Sabers.